Something rattling around loose inside this little guy. So today we're gonna look at a Messenger 175. Lucky us, huh? This is for a fellow Idahoan. So, native Idahoan. Not that it makes any difference where you come from, no one cares. Well, they do up north. Northern Idaho, man, you show up and you got a California license plate, your tires are going to get slashed and the car's probably going to get burned to the ground. And yeah, they really like things the way they are. They don't want nothing to change. I'll say that much. Okay, so let's see what we got here. Oh, hey. Oh. All right, a little piece of grass. Piece of phenolic board, and the high, medium, and low switch is shattered. Shattered. Ah, that sucks. Okay, well, shoot. Farts and dogs on a popsicle stick. I think I was looking around here the other day and I think I had a new input board. If not, we're gonna have to put a variable in it and make it work the old school way, which actually works better. But I seen one of those boards the other day. Where did I see that thing? I would have sworn I seen one of those boards the other day. Would have sworn. Let me look around here for a minute. Okay, so that's our input board on this little M175, which should do around 200 watts, you would like to think. That board is effed off, and I looked over all high and holy hell, and I can't find. It's one of them deals. It's like I'll save it for 16 years and then I'll move it and put it away, and then when I need it, I can't find it. Needless to say. So we've come up with a workaround. So the face of this thing still looks completely bone stock, the way we have it set up now. The only difference is, instead of it being low, medium, and high, we've got like a dial-a-watt. And what we've done is just gone ahead and put a variable potentiometer in here. Now we took the back of the case of the variable potentiometer and we put Kapton. It's a good insulator. It's got an incredibly low dielectric, very high temperature breakdown. And then we just put a resistor in there. So when you have this all the way turned down, this direction, all the way turned down, you're shunting all your input power to ground. But then when we turn this all the way up, all our power is going directly in. Now, this does not make a high drive amplifier. It's not what's going on here. It's still a very 35, 40 watt peak envelope power input amp. I took a minute and I cleaned it, made the faceplate so I didn't feel like I was going to get hepatitis when I touched the front of it. And I cleaned the Hepo crud off the outside of this thing. Also, give it a power wire upgrade so I could actually work on it with our pressure plates over here in the corner. So let's give it a minute, let's hook it up, and let's see how it works. So now the other thing that I did that I didn't cover in a previous segment is I repaired this LED board. The face of this thing got smashed in so hard at some point, that's what broke the variable. But it also broke off all four of these tabs across the back. Those of us that do this more than like a hot minute, we all know that that actually is a common problem. 1X. Make sure our on-off light works. It does. Preamp works. Indicator light also works. See if we can talk through it. Hello, 1, 2. We can. It's a 1,000 watt slug in peak, 1,000 watt slug in average, and a 5 watt slug in reverse back from the bird, 10,000 watt dummy load. Hello, audio. Okay. Alright, so we have no key up. Hello, audio. 1, 2. Alright, well, that's a problem. So is it that we're not getting 12 volts? Back over to the on-off circuit. What's going on here? Here we'll put a couple watt dead key into it. Hello, 1, 2. No going to transmit. Relays, no acting. No clicky clacky on relays. Let's go figure out why. I love simple problems. So with a voltmeter and a constant 12 volt hot source, keyed it and modulated it and found out that the relay, this little Omron here, was fuckered off. No longer wanted to work. It said, nope, me no key. What's up, baby? Come here. Wife just stuck her head out here like a ninja.
Hi. We're gonna just pop out the front door.
Oh. Okay, well, let's go deal with this. I have company. I shall return. Okay. Let's turn this back on. So, like I was saying, haven't played with the output tune yet. Just literally seeing if we got the relay working. Hooked up the positive leg of the probe to the volt probe here, and we could see that the transistor, the key-in transistor, was working down here. It was the relay. This relay is not wanting to latch. So now we have key up. Now this has got little 1446s or the little micro 455s or something in it. Okay. Hello, audio. It's 200 watts. Hello, and 12 volts. Let's show you drive. Turn off the little messenger. Hello, 1, 2. About 15-ish watts going in. So let's widen this back out a little bit. We'll scoot the amp up into perspective here. That's with the knob all the way to the right. Hello, hello, audio. Okay, that's with the variable all the way down. So we're getting about 75 watts out of it. Hello, audio. With the variable all the way down. And with the variable all the way up. Hello, 1, 2. About 200 watts. Remember, it's only rated to make 175 watts at 12 volts. So we did our duty. Now, in here, our biggest points of failure are these rods when it comes to messenger. And it always shows up as a cold solder joint either here or here on the board, or like here. See how close we can get before it decides to not want to focus. The most expensive camera in RF world, YouTube, and it doesn't have a decent focal. If we look closely at this joint, you will see that we have the beginnings of a cold solder joint here. See that darkened area versus the non-darkened area over here? But then if we look at this, you'll see that the tin color here is slightly different than the rod. So that means we have the beginning of a cold solder joint here and a cold solder joint here. This amplifier has both of the most common characteristics when it comes to a messenger failure. Between that and being overdriven, it usually shows up as these resistors here being burnt up. So it's a little bit of a game of knowing how long you want to make your inductors here to be able to achieve this as your input tune. So What we're looking at here is a 5-watt slug in reverse between the radio and the little messenger. Hello, that's the variable all the way up. Hello, and that's with the variable all the way down. That is more than acceptable. More than acceptable. Anywhere on God's green little earth, that's good. How that works out is like we're putting 20 watts in it and we're getting, not even a fourth of a watt back, which is beautiful. I mean, it's absolutely a wonderful match. So let's see what happens when we volt this thing a little bit. We'll go ahead, we'll crank the voltage up to about 15 volts. Let our super caps charge on up. Hello. Now with the variable all the way down. Hello. We're seeing about 125 out of it. Let's turn the variable all the way up. Hello. Hello. About 230-ish watts worth of power. Hello. Audio. I love the way this is set up because you can put about 1.5 to 2 watts worth of drive in it. Hello. Audio. And still have a substantially low dead key. No chance of you overdriving it. Always love these little guys. Fun little box. So, let's go fix our cold solder joints. And we're going to call this a win, because I'm pretty sure you guys aren't too overly interested in seeing me screw the case on. Just saying. Just saying. Let's go ahead and slide this over here. Refresh all these joints. Fixed. Okay. Wait for it to finger it out. See what I'm saying? Nice and smooth. Nice and smooth. All the same color. Okay. No cracks in the solid air. Well, gentlemen, we're going to call this a win. A win-win for the home team. Root for the home team. I'm off. I'm going to go back to working on this mega project I got going on. Just wanted to pump this one out here real quick. I got an X-Force I got to revisit. I've got a Sweet 16 I got to visit. This is going to be a busy week. It's going to be a very busy week. Lots of fun stuff coming up. Keep an eye on the YouTube channel. There's a couple things getting ready to come up for sale. We're going to save the board because the resistors are valuable. But the rest of this can go in the F-it bucket.